So one of them is called offset. Offset, this is the amount of stress that will result in a plastic strain. Like when I showed you my graph here, between the initial point to point what? To point C, we'll call it the permanent set. That is the offset there. So when I say 0.2 offset, it means that the amount of stress that will result in a plastic strain of 0.2%. That's what I mean by 0.2% offset. Is that taken now? When you say something is plastic, means it cannot what? It cannot how do I put it? It's if it is deformed, it cannot go back to the original shape. Is that taken now? That is plastic. If it deforms, it cannot go back to the original shape. Like if the material is maybe 1 meter, and I apply a load, like a weight here. If I apply a load here, now if I remove that load, it will not go back to that 1 meter. It will still remain the length of this. So you say such a material is what? Is plastic. So that is for offset for you. Now the next thing we talk about is elongation. Now elongation. So we say elongation, this is the measure of deformation before the material breaks. So that means from point B to what? To E is what we call the elongation. This is our elongation here. Now the next we'll talk about is the fracture. The fracture, this is where the failure of the material takes place at point what? Point E. The material starts to fail. It can no longer take the load anymore, then it breaks. The fracture is also called the breaking point too. Now the next thing is the gauge length. The gauge length is the original length, right? That is the gauge length, the original length, before you start loading. Now the next we'll talk about will be the reduction area. The reduction area. Now I said something earlier when I was treating stress. I said when I have a material this way and I apply a stress to it, a load to it, what happens? It gets thinner. The area gets smaller. When I mean area, the thickness. So that is the what? The reduction area. So tensile stress tends to reduce the area, the thickness of the material. Is that taken? As you apply this thing, the area reduces. Is that taken? So now the next thing is what we can say the reduction area. This is the ratio that expresses how much a material is narrowed when compared to original size. That's the reduction area. How much a material is narrowed when it is compared to original size. Now if you look at the original size is this, and when you apply a load here, it starts what? Coming down, reducing. So the next thing we talk about will be the yield strength. The yield point or the yield strength. Now the yield strength is the limits of elastic behavior. Below the yield point, the material will deform elastically. So like I said earlier, this is the yield point here. From here, if you stress the material beyond this yield point, it will not regain, it will become an elastoplastic material. It will not go back to its original shape and what? Its original shape and size. Is that taken? So now we'll proceed. I will go to the next one. So the next one we're talking about will be ultimate stress. If you look at this now, the ultimate stress, we say the ultimate stress here, this is the point that represents the maximum stress that the material can endure. At this point, the material can no longer take any stress anymore. Is that taken now? Before it fails. So beyond this point, failure occurs. Beyond it, failure occurs. Now